What up, world? It's your boy Louie, and here at ROBOTIC we build robots, and robots, they need wires, man, freaking wires. And wires, they have all kinds of connectors of different shapes and sizes. But I gotta tell you, man, it's a pain in the booty just to sit at a desk all day using a tool like this to put all kinds of connectors on lots of different wires. I mean, this thing would put stress on your hands. I mean, it's freaking painful just to make a fist. And we say enough is enough. So you tell you what, we're gonna build our own robotic crimpers. And your boy Louie here is gonna show you how.
Every design begins with a concept. And even in this so-called paperless age, pen and paper sketches still remain the ideal vehicle for recording that initial idea, before migrating to a computer design.
I'm engineering.
Looks like you're sleeping there.
Just a little bit. It's been a long day. Just finished designing the robotic crimper. All these parts are eventually going to be uploaded onto our system here.
Have you cut any of those parts?
Now that the parts have been cut and cleaned, it's time for them to get welded. Looks like the last piece has finally been welded. You said it's done welding? That can only mean one thing. Time for a paint job. Well, technically it's powder that's been charged up to 250,000 volts so that it adheres to the metal surface. The pieces are then put into the oven, where they will bake for about 10 minutes at 400 degrees Fahrenheit. Alright, now we're ready to assemble the, well, we really don't have a name for this part. I know, let's call it the claw. Alright, let's begin assembly on the claw. Alright, now you gotta make sure to lube it up. Never say that again.
And we're not just a bunch of hobbyists meshing machines together. We're engineers, man. I mean, look at these calculations. You have to go to school for this. But don't take my word for it. Take it away, Thomas. Thank you, Louis. So the beauty of this system lies on the fact that the downward force of the crimper, which can go up to 1,000 pounds at 400 inches per minute, by the way, is proportional to the motor's torque. And the torque is proportional to the motor's current. And the threshold of that current can be set using this Dow potentiometer. So, at the user's discretion, they can use this to control the power of the machine to suit just the right size of connector for the job. Alright, so we just finished installing this here console for the robotic crimper, and allow me to give you a basic rundown of the features. So we have the controller, which was programmed by yours truly. Here's the power switch. You can turn it on. As you can see, it's blinking on and off 4 times. That means it's going down the safety protocol. Just making sure that, you know, the voltage is good, the current's nice and low, and that no one's pressing this at the beginning of the program, because you don't want to accidentally crush someone's finger. We also have the dial right here, used to control the strength of the crimp. And as you saw before, here's the wire connecting to the foot pedal that activates the crimper. We'll just leave that on the floor for now. And you can also see these wires connecting to the motor.
Enough talk! Time to get into some real action.
See this crane right here?
Looks like this crane got crushed. This pen looks pretty demolished to me. Pencil? That's one mistake you can't fix. This can. Looks like this can just got crushed. And now to test this baby's real purpose, crimping wires. 14 gauge wire, 14 gauge connector. "12 gauge wire, 12 gauge connector." "10 gauge wire, 10 gauge connector." You know, thanks to this robotic crimper, crimping wires here at EvaTech won't be a pain in the butt.